All right, topic of today's video is composition of functions. So there's two sides to this, and I guess that's probably true with anything in math. There's the idea, or you could think of that as what it means. Like if you get an answer to a question, how would you know it was right, or how would you know what it was supposed to do or supposed to mean? And that's what I'm calling the idea. And the other side of it is just how you do the math, like how you get the answer. And those are two different things. The idea versus the process are two different things, okay? So I thought I would start with just the idea for this topic, and then we'll focus more on doing the math once we get this out of the way, okay? All right, so what is the idea? Suppose we have two functions. And here they are. I called this one f, and I called this one g. Okay? And what is a function? A function is something where an input gives you an output. So I'm representing the function like it's a box, and it's got an input terminal and an output terminal. All right? And just imagine that you link two functions together. Here's what I mean by linking them together. So suppose you put some initial number into this function, and we'll just pick any number just for the sake of example. How about a nice easy number like 0? So say 0 goes in, then out of this first function, the answer, the output would be 0 or 1 minus 0. So that's 1. Okay? And when I say I link them together, I want to take this output and now feed it into this next one. That's what I mean when I say I'm going to link them together. All right? So let's take this output right there and plug it into this one. And we'll get 2 times 1 squared. That's going to be 2. 2 minus 1 is 1. And 1 plus 4 is 5. Okay. So it appears that we put 0 in. And as these are linked together like so, we get 5 back out. Okay? All right. So that's what I mean when I say we're going to link two functions together. Okay, so what's this thing called the composition? The composition is one formula, one box, you could say, that works just like these two when they're linked together. All right? And so what's that going to mean for our example? I said, for example, suppose I plug 0 in and I ultimately get 5 out as these are linked together. Well, that means that if this one box works just like these two when they're linked together, then it ought to be true that if 0 goes in here, I would have to get 5 out. That's what it means. Okay. Now, we'll learn how to find that formula that goes in this box that works that way. All right? Okay, so now let's focus on how you find this. Hopefully from this first page you get the idea. You can take two functions, you can link them together, you can watch the numbers flow through, and then there's this one box, this one function that's the composition of these two that works just like them, all right? Number for number, 0 in, 5 out, okay? Now, as far as this symbol right here, that's g of f. That's how we read it. This is a circle. It's not a multiplication. It just means we're linking g and f together. F will be the first one, and g will be the second one. That's what g of f means, okay? So let's go now to how do you figure this out. See, I put a question mark. It was like, we don't know what that is yet. That's what we're about to do. We're going to figure out what this formula is, okay? So, all right. Let's say, how do you find g of f of x? So here I set it up where it's like the slide I was just showing you. You have f of x to be 1 minus x. You have g of x to be 2x squared minus x plus 4. And what is this one formula, g of f of x? Okay? All right. So let me write our process down here. So suppose I want to find g of f of x. Here's the way to figure that out. I take the g function and I plug the f into it. All right. So I take the g, I plug the f in. Now, that's kind of like putting a number in. I mean, you can take whatever you want and you can plug it into a function. All right? Like, let's kind of put this on hold for a second. Like, what's, say I wanted g of 2. What's g of 2? That says, for the function called 2, or for the function called g, let's let 2 be the input. What would it look like if you plug 2 into that? It'd be 2 times 2 squared minus 2 plus 4. And then you'd do the math, right? And you'd get an answer. But for now, I just want to emphasize, g is the name of the function. There it is right there. And whatever I put here is the input, okay? So when I write g of f of x, when I write it like that, and I'm plugging f, that entire formula as the input to g. Okay, so let's do like this. I'm going to write g down in a way that it leaves me space to plug in f, okay? If I was going to plug it in, it would go where the x's are, right? I mean, that's how, for example, if I was going to plug the number 2 as the input of that function, it would go everywhere you see there's an x. And then you do the math. Okay. So, all right, in my case, here's what that's going to look like. 2x squared minus x plus 4. There's g of x. 2x squared minus x plus 4. Now, notice here that it's like I erased the x. It's like if I took this formula and erased the x, that's what you'd get. And I did it that way because I'm going to have to plug something in. It's going to go in those blanks, okay? So just look at this right here. Like, all right, that's g of x. There's that formula with the x erased out of it so that I can plug something into it. All right, so now what am I putting in? Well, I'm putting f of x in. What's f of x? 1 minus x. So 1 minus x here, and 1 minus x there, okay? All right, so just look at that, and I want to make sure that you can see the layers to it, right? Like on one hand, you see g, 2x squared minus x plus 4, but on the other hand, plugged into it, you see f. That's what I mean when I say I'm going to plug the f function into the g one, okay? All right, well now we need to work this out. And by working it out, I mean we just have to do all the stuff that's there. The first thing that's here that we need to do is take 1 minus x and square it. So I want to do that here, okay? I'm going to do that separately, then I'll incorporate it into my work up there. How do you figure out what 1 minus x squared is? Well, to square something means you multiply it by itself, right? For example, 4 squared is 4 times 4, which is 16. So by the same thinking, 1 minus x squared is 1 minus x times 1 minus x. Okay. And then to do that, there's a procedure called FOIL multiplication. We multiply the first terms, 1 times 1. We multiply the outside terms, 1 times negative x. The inside terms, negative x times 1. And the last terms, negative x times negative x, that gives me positive x squared. Okay, putting this all together, I can combine those two like terms. I'll get negative 2x, right? Negative x and negative x is negative 2x plus x squared. Okay, so that's what at least 1 minus x squared is. 1 minus 2x plus x squared. So let's incorporate that up there. So okay, I got 2 times 1 minus x squared, but I figured that out to be 1 minus 2x plus x squared. Okay. All right, I'll have to multiply by 2 in my next step, but that's what I have so far. In here, I've got this negative 1 that applies to all of that. So I get negative 1 plus x, right? Negative 1 times 1, negative 1 times negative x. And then I just carry down the 4. Okay, only a few steps away, so I multiply here all the way through. Everything in there gets multiplied by 2. I'll get 2 minus 4x plus 2x squared. If I do that, I'll carry this other stuff down. And collecting all this together, all the like terms, I'll get 2x squared minus 4x plus x, so that'll be minus 3x. And then I'll get a 2 and a negative 1, that'll make 1, plus 4, that'll make 5. Okay, so this will be my answer. So there's the setup, here's the working it out, there's my answer. So I'm going to write my answer up here. G of f of x is 2x squared minus 3x plus 5. Okay, that's what I was looking for. All right. Now, so I have my final result. I still want to test that against what I was saying would happen on this first page. If I find g of f, I'm going to be finding this one formula that behaves like these two when they're linked together. Let's see if that's true. Okay, so what did I find? It's no longer a question mark. What did I find g of f to be? It was 2x squared minus 3x plus 5. Okay, and the way that ought to work is if I put 0 in, I should get 5 out because it's going to behave like those two. And that's in fact true. If I put 0 in, I get 2 times 0 squared, that's 0, minus 3 times 0, that's 0, plus 5, that's 5. Okay, so that confirms that it's correct. Because that's what we would expect to happen. That's all I'm saying, right? Now you could take some other number if you want to, just for the sake of experimenting, if you felt inclined to do it. Take another number, plug it in here, let it work its way down, get something there, and then see that the same thing happens over here, okay? All right, so that's both the idea and how you find the formula. So that's both sides of the coin. So with these two slides, you've seen both sides of the coin. All right. So next thing, let's just do another one that's just for practicing the technique, okay? The idea is not going to change, all right? The linking, that's not going to change, and I could draw the boxes every single time I do one of these. But I think what people have the most trouble with is just practicing figuring this out, okay? So here's an example where I have f and g. All right, two functions are given. I want to find these compositions and then see what I get with those inputs, all right? Now let's not worry about these last two for now. Let's just work on the first two, and then we'll talk about the last two. So as far as this one goes, I'm going to do my work down here. What's f of g of x? Okay, so I'm going to do that one. Okay, well, so if we just like follow the lead I had in that other problem, that means to plug g into f. All right, but g is going to be the input. G is the thing I'm going to plug in. If I'm going to plug g into f, where's it going to go? It's going to go where the x is. In all of our functions, the x indicates where the input goes. So I'm going to take f and I'm going to write it like that. 5x minus 1. 5x minus 1. 5 input minus 1. The input is g. All right? What's g? 5x squared minus 1. So you see the layers to this. First I wrote down f, but then I'm plugging g into it. You see both of them there. All right? Okay. So once I get this on paper, then I just work it out. Like, so for example, what can I do here? The only thing I can do here initially is multiply everything in there times 5. So I'll get 25x squared, 5 times 5x squared, minus 5. 5 times negative 1, and then I subtract 1. So combining a little further, I get 25x squared minus 6. Okay, and that's as far as I can take it. So that's my answer to f of g. So let me write all my answers up here. F of g turns out to be 25x squared minus 6. Okay. So what about g of f? All right. So g of f. Just by analogy to that, it would mean take the g function and plug the f into it. Okay? So that's going to be my input. So if I'm going to plug something into g, I need to write g down with, like, you know, imagine I'm erasing the x, right? 5x squared minus 1. There's g. That's the g function. 5x squared minus 1. Into that, I'm plugging in f. 5x minus 1. Okay. So I've got it set up. I'm going to work this out now, okay? What could I do here? Do exponents come first, or does the multiplication? It's the exponent, then the multiplication, okay? As far as the exponent goes, when you do 5x minus 1 squared, that's like 1 minus x squared. You multiply it by itself, and you do FOIL multiplication, all right? So here's what you're going to get if you do that. If I do 5x minus 1 times itself, I'm going to get 25x squared minus 10x plus 1. Okay, that's what 5x minus 1 times 5x minus 1 is going to be. All right. Now that I got that, everything I found here gets multiplied by 5. So I'll get 125x squared minus 50x plus 5, and then minus 1. One more thing. I can combine the 5 and the 1, so my final answer will be 125x squared minus 50x plus 4. Okay, so g of f of x, it's right there. Okay, let me write my answers up there, though. Okay, 125x squared minus 50x plus 4. All right. Okay, so we got those. I hope you see the same technique for both of them. All right. The order's backwards, but I didn't really do anything different other than that. Okay. What about these? Well, okay. So anytime we put something here, that's our input into the function. So like when I put g of x right there, that's the input into the function. Or when I put f of x, that's the input. So when I put negative 2, that's the input. Okay? You could think of it like this. Like, that's the input into the function. And you could always think of that part as being the name or the label. Like this function's called f, and that one's called g. This one's called f of g. So this says that into the function by the name or label f of g, have the input plug in negative 2. Or f of g is this one. There's its formula. What would that look like if you put negative 2 in? Be 25 times negative 2 squared, take away 6. Okay? So negative 2 squared is 4 times 25, that's 100. 100 minus 6 is 94. So into this function, if negative 2 goes in, 94 is what you get out. A function is inputs and outputs. Think of it like that. G of f, all right, same thinking. By the function that has this name or label, G of f, which I see right here, I'll plug in the input negative 2. What's that going to look like? Well, here's the formula for G of f. 125 times negative 2 squared minus 50 times negative 2 plus 4. Okay. All right, so doing the math. So that's 4 times 1 is 500 right there. And this will be plus 100. And then plus 4, right? We do all the math, so we'll get 604. Functions are numbers in, numbers out, inputs, outputs into the function by this name, this label. If negative 2 goes in, 604 is what you get back out. All functions of I could have made it like this. Negative 2 goes in. We do all the math. 604 is what you get back out. Okay? All right. So now you've seen now 2 examples like this where we focus on how you do the math. Let's look at one that's kind of, I guess, that requires that you understand that the composition is the same as linking the 2 functions together. All right, so we should do one like that. And so here it is, okay? So it says, by the information provided in the graph, can you calculate f of g of negative 3? Okay? All right, can you calculate f of g of negative 3? Here I see things like, on this graph, there's numbers. It's not the scale. There's shapes and numbers. Each graph is drawn. And when I say something like, say this point's on the graph, and 4 is the x-coordinate, and negative 6 is the y-coordinate, then that means that into the function g, if you plug in 4 for x, then you get negative 6 back out for y. Right? Inputs and outputs. That's what that means. And this point right here says into the function f, if you put 2 for the x, you'll get 3 for the y. Now, I don't have the formula. That part's not provided, but it doesn't matter. Really, the function is just the numbers. 0 in gives you 1 out, or something like that. Whether you have a formula to figure that out, like these, or whether that information is just given to you, it's all the same information. Okay? So how about let's do it this way. What's f of g mean? It means take the g function and link it together with the f. Okay? So this right here, that's f of g of x. F of g of x would link these 2 functions together, g first and f second. And if I want f of g of negative 3, that's like saying, well, I'm going to have negative 3 be my initial input, that first number I plug in. Okay, let's follow that all the way through and see what you ultimately get out. That'll be our answer. Okay? And when you put this number in to that linking, what is your final output? That's all we're looking for. So let's start this way. Into the g function, if you put negative 3 in, what do you get back out? Well, so g's right here. And that point says if I put negative 3 in, I get 0 out. Okay? So I get 0. Just by that point, that's what that says. For g, negative 3 goes in, 0 comes out. There you have it. But we got these linked together, so now we put 0 into f. So what do you get out if you put 0 into f? See this point right there? It says if you put 0 into f, you'll get 3.5 out. So that's like our ultimate output into f of g, which looks like this. If negative 3 goes in, 3.5 is what you'll get out. Okay, 3.5. All right. It's just like that first thing I showed you. It is really just like this. Except for we don't have formulas to do the math with. We have to look up what the inputs and outputs are on the picture, on the graph. But it's the same information. Okay? All right, so last thing I want to do was take like something that's realistic as possible. I mean, this here is not a word problem. These are just formulas. I just made them up to illustrate the point, okay? But I can provide you with something that's somewhat realistic if you'd rather think of it that way. Okay, so let me show you what that is. So you're going to have to imagine along with me a scenario real quick, okay? So suppose we buy an item, and the item will have a $15 discount applied to it, all right? So I take it you know what a discount is. There's just going to be $15 off. But then you have to apply 8.25% sales tax on top of that. So the item like has a price on the shelf, but you get a $15 discount to that. After the discount's applied, you got to add the tax, okay? And here's all the functions I want to find. Can you find a function that only applies the discount? Like a formula that just takes a price and applies the discount. And can you find a function that only applies the sales tax? Now, what do we want to happen? We want a formula that applies the discount first and then adds the tax. That would actually be g of f. If this was f and that was g, this would be g of f. That's what it would do. All right? Okay, so let's see if we can figure all that out. First of all, f of x. That one will be pretty easy. X is the price of an item. F just applies the discount of $15. That's what we said the discount was. That's easy. That's just x minus 15. Okay. That one is pretty simple. What about g of x? All g of x takes the price of the item and only adds the sales tax. Okay. So g of x, that's going to be like this. We'll take the price of the item, and we have to add 8.25% of the price. So we're going to take x, the price, plus 0.0825 times x. Okay, that would do it. That would take my price and add 8.25% of it. All right, that's adding the sales tax on. Now these are like terms though, so we'll go ahead and add them together. Like this is 1x and that's 0.0825x. So you can add the coefficients when you add like terms. So 1.0825x, that's going to be g. Okay? If you want, maybe it wouldn't hurt to give a quick analogy to what I just did there. It's kind of like if I said, what's 7x plus 4x? What's 7x's plus 4x's? Well, if you count them up, 7x's plus 4x's, that makes 11x's. But all we do to get that is take this number plus that number, x. 7 plus 4, x, 11x. So here I got 1 plus 0.0825, and that's my coefficient now, okay? All right, so there's g. Now let's find g of f, okay? G of f would, well, what did we say the order was when we linked these together? F first, G second. So first apply the discount and then add the tax. That's the order this is going to do things. Okay. Well, so let's see if we can figure this out. So we need to take, what were my instructions for doing that? Take F and plug it into G. What's G look like? Looks like that. All right. if I erase the x in order to plug something else in, then I get like that. So this right here is G 1.0825x. 1.0825 times the input. What are we plugging in? We're going to plug in this other formula f, which is x take away 15. Okay. All right. So let's do one thing to get our answer. Just multiply all this together. That's all there is to do right there. All right. So as far as what that is, I'm going to get 1.0825x, but then I got to take 1.0825 times 15. And I don't know what